So I want to thank you guys for joining for the February 28th Community Sync. And I'll go over a little bit about the community updates and stuff. So we'll do a little stats and updates, and then we'll go over Daniel Ford's journey with Hudi, and he's from Funding Circle, so we'll talk about that a little bit. And then at the end, we'll have time for a Q&A. So for the community sync, we've had over about 114 pull requests that have been merged, which is really awesome. We're working really hard, and we're also working actively to close down some of these GitHub issues. So if you create them, there's a team of us that's trying to make sure we resolve them. And if you also post questions on Slack and stuff, it's usually me going around and answering the questions. And I always try to follow up. So feel free to ping me if you feel like it's been a day or so and I haven't responded. But otherwise, we do our best to rope in the right people to help answer your questions. In terms of growth, we have over 4,000 Slack users, yay, and we're just shy of 5,000 GitHub stars. So if you're tuning in and you like or use Hudi, or you're just a fan of it, please start us on GitHub. I'll share the link in just a little bit, and it'll be great to get us to this 10K mark. And then we have an upcoming major release for 0.15.0. I'll share that in the next community sync, and then I haven't seen any new RFCs. So for the community, this is the different ways you can join. I'll also share the GitHub again. And if you haven't followed us on the Hudi LinkedIn or Hudi Twitter, please do that. We'll be sharing some really cool upcoming content in the next few months, and we're always scheduling new stuff. So I hope this will be helpful in your journey with not only Hudi, but just in data infrastructure, data engineering as a whole. So with that, I'll go ahead and stop sharing my screen. And Daniel, I'll pass it to you. Let me go ahead. Let me know when you're ready to share.
Yep.
Okay.
Yeah, no, I think I'm ready.
Cool. I'll let you take it from here.
Is that good? Yeah, you can see. Okay, I assume that's a yes. Yeah, I'm Daniel. I work at Funding Circle, and today I'm going to go through our journey with Apache Hudi, primarily from end of 2022 to midway through 2023 was when we did most of our development, and talk about our lessons learned and kind of what the future looks like. Why is that not? Okay, so yeah, I've said that before. I'm a data platform engineer at Funding Circle, but what is, oh, sorry, never mind, wrong slide. And I'm going to go through kind of the company overview and the initial requirements that we built our tooling around, the current solution, an overview of the architecture, what we built, what we learned along the way, how we improved, how Hudi helped us improve, what we did, the business impact it had over what we had previously, and as I said before, our future with Hudi and kind of the future of our ingestion platform. So what is Funding Circle? Funding Circle is a lending company where we build the place where small businesses get the funding they need to win. We do so by delivering an unrivaled customer experience powered by data and technology. Our instant decisioning engine allows these small to medium enterprises to complete applications in minutes and really receive a lending decision in seconds, allowing them to access funding at a really affordable rate. And so far, we've helped over 135,000 businesses access more than £15 billion. So that's what Funding Circle is. What is the goal of the data platform? I'm a data platform engineer. What is the goal of the data platform? Our goal is quite simple. We want to enable users to drive kind of business outcomes and business decisions by making it really simple to work with data. We want data product developers to be able to build at pace without necessarily having specialty data engineering knowledge. And we want data product users to be able to discover, find, use, and maybe even build off of data without kind of need for support. So kind of simplicity is what we're going for, and the data platform aims to provide that. So Funding Circle's data platform is quite a broad endeavor. We are heavily AWS and Kubernetes native, and we provide abstractions and tooling for a range of different things, like processing and data transformation, visualization and modeling, querying, access control, orchestration, metadata discovery, or kind of allowing people to create, add metadata and house their data products, etc. Like the list goes on. And we do so at a varying amount of open source versus managed solutions, at very different levels of abstraction. Sometimes we provide quite low level interfaces, and sometimes we provide fairly abstracted and kind of neatly packaged solutions for people, depending on the use case. So back in September 2022, that one of the data platform teams, one of the ones that I work in, had the task of improving our existing legacy Kafka ingestion solution. We had a simple config-driven interface to allow people to ingest data from directly from Kafka and have it end up in a queryable manner in Glue. So syncing the data to S3 and using the Glue data catalog to allow that to be queryable in Athena. This was made back in 2018, 2019, and it had a whole raft of problems. Scheme revolution was often unstable or even unviable. The code was massively complex and very, very legacy, predating almost every engineer that's currently in the data platform team. The pipelines were centralized. They had centralized deployment and centralized management of these pipelines, which didn't really directly support our data mesh or like self-service ways of working that we aimed to achieve. And there was no real way of establishing end-to-end domain ownership of a data pipeline. Couple that with like a lack of observability, and it's doesn't even nearly support near real-time ingestion. We had a lot of things to improve on. Also to note, backfilling times were often prohibitive. If someone had a large topic they wanted to sync, sometimes it was simply not possible to do it via Kafka because the syncing speed was so slow. So we went about and we designed, and what did we design for? We wanted data to be available in under 10 minutes. We wanted scheme revolution to be a thing of the past. We just wanted it to work. We wanted all of the data ingested, or like data products created using the tool to be discoverable in our metadata platform. We happen to use Data Hub, if anyone's aware. And we wanted a lot of the usual bells and whistles, including like monitoring, alerting, scalability, cost effectiveness, kind of like PII is masked, declared by the user and just masked and is just handled for them because it's a real sticking point for our users. We also kind of wanted, as a nice to have it be as decentralized as possible. We wanted people to be able to declare their own pipelines in their own repos. So that was just some of the things that we designed for. So we spent 6 or 7 months developing, and what did we come up with? We came up with the Kirby project, which is an acronym, although it's probably going to end up with a Nintendo lawsuit. But it stands for Kafka ingestion, real-time or batch through YAML. So it's a terrible acronym, really. But yeah, what does that mean, I guess? It's a very complicated diagram, but I've tried to split it up into 3 main parts. In this blue section, we have our kind of declaration and deployment section. In the middle, we have our compute layer, and on the right, we have our access layer. I'll quickly take you through a few key points of the tooling that we developed, just to kind of like show you what that user experience looked like and how we were using the Hudi Delta Streamer, or the Hudi Streamer as it's now called. So first up is the user's interface with the tool. So what does a user have to do to actually make this work for them? It's very simple. They just have to define 2 things. One of them is a YAML pipeline definition. So this just sits inside their repo quite simply, and they provide their metadata up the top. I don't know if you can see my mouse, but you've got things like the region of deployment, the domain that owns this pipeline, or the actual owner, so like the team owner of the pipeline, and then some just data about the actual pipelines themselves. And then it's deployed simply by being put into a drone pipeline or a GitHub action. So it can be used depending on what the users are familiar with, drone or GitHub actions. We're fairly heavy on both at Funding Circles. This was quite familiar to a lot of people. So that's the usage. What happens next? These YAML definitions are parsed by the plugin at runtime and turn into generated Airflow DAGs. So from this point, users are able to run or like see the progress of their jobs. They can see the history and status of their running Airflow EMR steps. To avoid exposing PII, we extended the EMR steps operator to inject our kind of secrets manager secrets at runtime. That's worth mentioning. And so in the right here, also pictured, for the first time, users were kind of like automatically in charge of their pipelines, which directly supported this data mesh ways of working to help establish this end-to-end domain ownership. So as you can see, like from the metadata of these DAGs, we can easily see things like the version of the tool that they're using, the repository that the data sits in, the team name, the type of pipeline, and the domain that the users sit in. So they can deploy this without our knowledge, but we still have kind of some way of centrally understanding the growth of the usage of the tool, which was super important to us. Up next, so lastly, the last thing in the declaration deployment section is kind of on the subject of end-to-end ownership. The tool also deploys a CDK stack for all of the AWS resources required for their pipeline. So this CDK stack is also instantiated when the plugin runs, and it abstracts all the AWS infrastructure creation, management, and access control away from the users. So this just works for people, which they love. And it helps us to provide kind of the guardrails for a scalable and maintainable data lake. Lastly is the primary reason I'm here. Our jobs run via the Hudi Streamer on EMR in both batch and streaming configurations. I said this before, but they directly ingest from Kafka on our centrally maintained EMR cluster. Next, I will take you through kind of like the benefits and the learnings we gained from both EMR and using the Hudi Streamer. Before I do so, can I do questions in the middle, or should I wait and do questions at the end, Nadine?
Yeah, you can do questions whenever. I haven't seen any questions in the box yet, unless you see them.
No, that's fine. Okay, if there are any, then post them. Okay, I don't want to lose people. Just let me know. I can't see them.
Oh yeah, and this goes without saying. If you guys have questions, definitely drop them in the box. Thanks. Okay.
Yeah. Okay. Cool. Yeah. Lots of talking. Apologies. So okay. A bit about the EMR cluster. It was our kind of chosen compute option early for our Hudi Streamer on Spark workloads, and this was for both regular and continuous Hudi Streamer jobs. The pros of the system is that at this point it's relatively stable, but the cons are numerous. It was a huge learning curve for the team to kind of get up to speed with the fundamentals of like Hadoop frameworks like Yarn and HDFS. So for a young team of engineers with no prior domain knowledge, this was like a significant hurdle to overcome. There's also a wealth of Yarn and Spark job communication issues, which we found quite prohibitive during our development. And it's also quite expensive to run. It's for the kind of the above 3 reasons, it's not suited well for running these continuous jobs. And it's hard to debug and diagnose issues for other on-call engineers, I guess, because of the huge learning curve and the size of our data platform team. It kind of created knowledge silos quite quickly. And it creates a singular failure domain for our compute. So if like our cluster goes down for whatever reason, that is all of our pipelines are gone, or they need to be restarted, which was not ideal. We had a lot nicer of a time working with the Hudi Streamer for sure. We run the Hudi Streamer 0.11.1 currently on EMR 6.8, I believe. And the benefits are massive. It provides a hugely valuable tool for ingesting a wide range of sources into Hudi tables. Although we only use it for Kafka currently, like there's obviously the ability to extend that. We love how it natively integrates with our Glue data catalog and our Confluent schema registry, and it just automatically handles all of our schema revolutions and catalog updates for us. Once you kind of get your tooling down, it's very, very simple to execute it in a simple config-driven manner, and the excellent community support is definitely the best I've ever encountered. There was a few learning curves, obviously, with anything. Debugging issues without Spark and this Hadoop understanding, like I said before, led to a lot of red herrings and doubling back in our investigations because it was hard to diagnose what was going on. One of the other learning curves was building a deeper understanding of the Hudi Streamer and its configurations, which helped us be able to debug more efficiently. But this was definitely a lot slower at the beginning of our development, our development timeline. One of the other learning curves was kind of understanding and diagnosing like AWS related issues. So although the Hudi Streamer might be doing its job, our AWS backend was throwing errors quite frequently. It took a lot of time for us to start to get up to speed with understanding where the underlying issue is and diagnosing that quickly. But these are learning curves that we are on the other side of, thankfully, and it was definitely worth doing. So yeah, what are we doing now? That was in midway through 2023. We currently service about 80 topics across the UK and US with a range of batch and streaming workloads. As I say, this is a decentralized tool, so we have kind of let the users come to us. People generally love using the tool. That volume is expected to grow to around 200 plus over the coming 1 to 2 years. And as I say, yeah, we've been in maintenance mode now for a good few quarters. The thing in the screenshot is just showing that we have a range of batch and streaming workloads running. So like one of them running there has been going for 8 hours, but the other ones have completed and have been running for a matter of minutes. I'm going to go through a few learnings now. There's learnings that we have had about the Hudi Streamer. There's one for EMR and there's one for project management, and they're all worth mentioning. So with the Hudi Streamer, the challenge was originally that we kind of hoped and assumed that the Hudi Streamer would be some very, very simple click and connect tool that we could deploy that would just work for our entire scope. The problem with that is that edge cases gradually arose kind of away from this happy path that we tested for, which made us realign our expectations from our initial scope. Essentially, there is a batch of topics that currently exist that can't be ingested through the Hudi Streamer, which is something we would have worked out had we had the debugging and testing proficiency when we started the project. So what can we learn from this? In future, we can test more effectively to ensure our solution fits our entire scope. We also learn to lean even on the massive wealth of experience that Hudi community has to offer. And over time, we've gotten a lot better, and we've even started helping other people out. So yeah, it was worth learning about for sure. In terms of project management, we kind of fell into the pitfall quite early on. We were very, very excited about using the Hudi Streamer's capabilities after learning about it, and the Hudi table format itself. We found that quickly diluted our scope, as we kind of wanted to be able to provide everything, like all these cool features, and we made a lot of promises at the beginning, that we found that we in the end either didn't need or couldn't keep the promise. So initially, like very minor requirements, like being able to use time travel querying, was like key deliverables because we thought it was really cool. And it detracted away from our initial goal, which was simply appending Kafka data and having it queryable in Athena very, very fast. So in terms of learnings here, it's more hindsight is 2020. Like, it's been a year and a half since we first started learning about all of this in terms of Kafka, Hadoop, Spark, Hudi in general. As a team of engineers, we're now far more mature and capable to build a kind of second revision, having gained this wealth of knowledge. So yeah, our learning is not to rush into things next time and assess our business cases. In terms of EMR, not much good things to say. It's been an extremely steep learning curve. No one on the team had ever maintained or used an EMR cluster before, which is a big learning curve. A large majority of the issues faced on this project can directly be attributed to our lack of experience in maintaining like a dynamic EMR cluster. This led to constant setbacks and kind of slowdowns in being able to diagnose problems, and whether it was actually the Hudi Streamer or whether it was EMR itself. So where are we at nowadays with that? Issues still crop up occasionally, but the team now has a fairly firm grasp on how to maintain our cluster in a sustainable, scalable manner. So the learning would be, don't provision your own EMR cluster unless you really need to. But I do feel that the community could probably use a guide or like a template to get a resilient EMR cluster working quickly, and like a document on the considerations, which I am considering making. So that was a bit doom and gloomy with the challenges or the learnings, but what are the achievements? So there was achievements for us and there was achievements for the users. So for the users, automatic scheme revolution is a huge one. As I said before, having access control and PII masking just be config driven is a huge win. This decentralized deployment firmly puts the creation and maintenance of these data pipelines in the user's responsibility for the first time. Users love the user experience. Our 1 hour refreshes, whereas before we were running things on like maybe a half hourly or 1 hourly kind of increment to load the Kafka data, that's now 3 to 4 minutes. We've gone from batch workloads to the potential of real-time analytics, which enables kind of like fresher data for our users, and has opened up like a new paradigm for self-serve analytics at the company, which is really, really cool. Backfilling is now no longer prohibitively difficult. So instead of working around a hacky solution to backfill data into the lake from these topics, we can now just use the same tool for that task, which is really, really huge. That, and we've got some nice custom integration with our data hub instance to be able to directly attribute the tool to be the bridge between the Kafka topic and the Athena table for our column level lineage, which is also pretty cool. So that's what the users had. For us, we have made 2 open source contributions to Hudi since we began, which was really, really cool. And we've raised double that amount in GitHub issues, which I'm told is also cool, also a good thing. Probably gained 1 Nintendo lawsuit probably with our branding choice, but I can always hide the Kirby images if anyone comes looking. And most importantly, I think we've gained tons of learning. We've learned about UX design, file formats, Hadoop, EMR, Spark, Hive, Glue, a lot of it. We are so much better for having taken on this project. So it's been very, very cool to see that kind of like that grow over the past year and a half. at the bottom line, what has Hudi's impact been on Funding Circle? So on the kind of topic of the rapidly decreasing refresh times, like it can't be understated how useful it'll be for our analytics teams to be able to have minute level refreshes as a possibility for their work. And as notoriety of the tool grows, so shall the use cases. We're expecting to see more of these real-time use cases come out the woodwork now that the wider business will start to know that that is possible for us to do. In terms of backfilling times, as I said before, massive scale backfills are now taken from weeks to hours. Internal engineering teams can now simplify their ingestion workflows drastically, which gives them more time to focus on building quality data products for reuse across the company and just focus on other operational efforts. So they shouldn't really be, it's just giving them more time in their day, which is super, super valuable. Scheme Revolution has gone from some expensive full load activity to just an afterthought. Engineering effort has been drastically reduced because this is no longer a manual effort, and data producers, importantly, have like massively increased confidence in their ability to just evolve the company's schemas without fear of breaking the legacy tooling. Most importantly, in my opinion, though, is, as I said previously, like Hudi was the catalyst for us learning about and applying table formats to our platform for the first time. And because of this, and because of our understanding now, we've started to identify a wealth of other potential use cases for Hudi across the platform. Into like a lot of it's to do with migrating legacy pipelines to more CDC pipelines, starting to use upserts more in our pipelines, etc., which would be really simple to achieve with our existing knowledge of the Hudi Streamer. So that's pretty cool. What is next for the Kirby project? Yeah, so we're not currently looking to do anything, but on the back burner for easier maintainability, we'd like to reduce our reliance on EMR and Hadoop. If it wasn't already obvious, I'm not the biggest fan of EMR, and instead we'd look to move to something more lightweight and familiar, like Glue, for specifically our batch workloads where time criticality isn't as important. I said this previously, but currently around 20% of our topics at the company aren't directly ingestible from Kafka via the Hudi Streamer. So we'd like to investigate using S3 as the Hudi Streamer source for these topics to enable that 100% coverage. We think that's quite important for our users to not have to think about whether their topic is ingestible or not. Seems like a no-brainer to look into. And we would love to keep the UX and the tooling designed, the tooling that we've designed around the Hudi Streamer for our users as this familiar interface. We would like to extend it to users to be able to ingest other data sources, such as our wealth of SFTP sources, API sources, S3 ingestion. They're all currently being looked at. Next one. So yeah, one thing's for sure is Kirby and Hudi are primed to be the beginning of our future ingestion platform. I can say that with big confidence. And to thank the community, to shamelessly plug Nadine, who definitely didn't ask me to add this. You always follow up on my questions. Thank you for inviting me to talk today. Aditya, I don't suppose he's here, but he's usually the unfortunate one that Nadine gets to answer my stupid questions. Siva personally spoon-fed me my first Hudi contribution, which also happened to be my first open source contribution ever, which is very, very cool. And also in Java, which I don't know, which is even cooler. And Sunil, I don't know if he's here, but he provides most of the guidance and kind of inspiration for improvements to this tech stack that I've kind of displayed today. So yeah, thank you very much to everyone there, and anyone who's ever helped me. I would like to open up to questions. If that's
all right. Thanks, Daniel. Yeah, we're really happy to have you as part of the community, and definitely like to thank you for giving the community sync. So, and the team is always willing to help all of the Hudi community users to be proficient in Hudi. So we're really excited. Ankit has a couple of questions that he posted, so we'll go over them. One of the questions he asked is, "What are the best practices for data model that you use in your architecture?"
The best practices for our data model. So in terms of a data model, we are pretty lake based. So our project was for essentially mirroring Kafka in the data lake in a queryable format. So our chief concern was, simply copying that. So it was essentially mirroring that and making sure that the schema in Kafka matches the schema in Glue. So as long as backwards compatible schema revolutions were allowed, in Hudi as well as what is possible in Kafka, we were fairly happy as the Hudi streamer could model that. So the model itself wasn't our concern really. We were just trying to emulate Kafka.
Ankit, let me know if this helps answer your questions or if you have a follow-up. And he also asked, why did you choose Hudi?
Why did we choose Hudi?
Yeah.
We originally chose Hudi because the Hudi streamer achieved what we wanted to achieve very quickly. It was done originally as a POC, where we used the Hudi streamer to do kind of schema revolution on Parquet data, and we thought that was really cool. And then once we found how quick the Hudi streamer was, that quickly became a big focal point. Like ingestion speed was very, very important to us, and the Hudi streamer on Spark was able to accommodate that. We had pretty simple requirements at its core. As I said, it was have schema revolution be handled and get Kafka data into the lake fast without having to worry about it. So that's why our solution quickly started revolving around the Hudi streamer.
Oh, go ahead.
No, and Hudi in general. That's all I was going to say.
Did you have other technologies you were considering, or was it just automatically Hudi?
We looked into, I believe, Iceberg on Glue, and we also looked at kind of using Hudi on EMR serverless and potentially EMR on Glue. But I think back in the time, we couldn't get POCs working essentially. So we were our solution was very kind of path of least resistance. We knew that we could get this working in EMR, so we kind of put all of our eggs into the EMR basket and the Hudi streamer basket, and then built around that.
Another question he asked is, what kind of process you followed and time to decide? I'm assuming that's maybe a project management question. Ankit, if you wanted to elaborate more on that. And then the other question he asked is, can you describe one use case for self-serving analytics in your architect? And who are the target audience for the self-serving use case?
Okay, yeah. So self-service analytics. So we as a central data team don't want to be involved with the day-to-day creation of data pipelines as the data platform team. We want to enable, if it's data engineers who are working on creating a data pipeline, or product engineering who have created an application that they have a requirement to get data into the lake for, or whatever it is. If people have a topic in the company and they know they want to be able to query it in Athena, which is a very, very common use case for our company is very, very heavily invested into Athena, then we wanted people to be able to do that very simply, with just some copy and pasting and minimal copy and pasting ideally, and just following a guide to build out their YAML file. So that's basically it. If there's we have a lot of cross-functional teams. So in those cross-functional teams, you might find product engineers and data engineers who are closely talking to analysts who are working on a product together for the business, and they need to be able to move fast and move kind of like horizontally. So for that reason, we wanted to make self-serve tooling. So, self-serve tooling that just works and is very kind of like beginner friendly to accommodate that. That's the idea. Like, as a central data team, we want to be doing as little as possible, and we want to save the actual work to these cross-functional teams who are creating these data products.
Which brings us to the next question. What is your definition of a data product, or maybe what's a data product in Funding Circle?
Oh, okay, that's a tough one. Okay, it's late. A data product is essentially it doesn't have to be a data set, but it is a set of information that is high quality and curated to answer usually to answer a business question, or to emulate the state of a source system. There's multiple different types of data products. There is source-aligned data products, and there are consumer-aligned data products. Based on what we're doing, I will talk about source-aligned data products. So the idea of the source-aligned data product is to create in this instance, it's like a data set, but it is a high-quality data set that has clear ownerships, has clear definitions, has clear data contracts between kind of like producers and consumers, and it has a wealth of metadata to make it just high quality in general. These data products should also be kind of discoverable by the wider business, and people should be able to use them kind of like atomically, like kind of a pick and mix kind of thing, to build other data products potentially out of these high quality data products that are presented to them. And when something goes wrong with like the upstream or the downstream, there is a clear ownership chain to follow, and there's clear interfaces between the producers and consumers at these different levels. If you ask people what a data product is, you usually get a different answer to everyone. Like, I've been at conventions where like I went to a data product talk and about 10% of people put their hand up when they asked what a data product is. But to me, that is what that means, and that's what we're aiming to do. Essentially, you can boil it down to high quality, owned, curated information that is ready to be used by consumers with confidence.
And then another question that was popped up was, what's one example of schema evolution that's worked, maybe that you can share? Or what's an example of how your schema has evolved?
Oh, so our schemas change all the time. Like, if we have a Kafka topic that is being produced by an application of some description, and the product engineers decide that they need to add a bit of information, to that record or something, then as long as it's backwards compatible, then we want that to be reflected in the lake. We want the schema in the lake to be the latest schema of the topic that it's trying to emulate. So we have additions of massively nested fields. We have a lot of different operations going on different types, and we provide people a schema evolution kind of like possible, not possible list to follow. And the job is then on the product engineer who's making the change to the upstream topic to make sure that the changes they're making won't affect their downstream Kirby pipeline. But yeah, if you're looking for the schema evolution capabilities of Hudi, like it's on the website and it's quite expansive. And
yeah, I can share the link. I can share the link right after this too.
But Yeah, as long as it's a backwards compatible schema evolution from what I've seen in Kafka, then it can be reflected in the Hudi table. Hudi maintains its own internal understanding of the schema, and then it will, using the Hudi streamer at least, it will sync that schema to your Hive metastore of choice that we choose to be Glue. And that allows us to constantly be up to date. If the schema updates upstream, then within minutes, that is the schema in the Glue table. This is obviously like configurable. We don't have to have that be the case, but for us, that was very important that producers are able to change their schema upstream, produce messages with that new schema, and then very quickly be able to confirm that that is okay in the downstream table that they own.
And then, at what point in your is data quality check performed in the architecture you shared?
Okay, so data quality checks are predominantly done. So data quality checks are often done on the actual topics themselves in the application codes that are producing the messages, as we're still talking Kafka here. But also, data quality checks are becoming more and more prevalent in the downstream. Our current kind of workflow is that Kirby will sync a topic to a Glue catalog table, and then we are also very heavily dependent on DBT for our transformation and modeling stage, at which point a wealth of DBT tests can be run on that downstream model. But in terms of kind of like actual data quality checks that we have when syncing the data, we do not actually have checks there currently. But it is possible to do that with Hudi if you so please.
One question that was asked is, are there any learnings on new sources that need to be supported in Delta Streamer?
Are there any learnings on what could be supported with the Delta Streamer? As in like what would I choose to be a new source?
Yeah, I guess that's how I'm understanding. Sudha, if you want to elaborate a little bit more. Or I guess if you had a new source that you want to be supported in Delta Streamer.
It's a pretty generic one, but like I'm actually not sure, but like it'd be external, being able to incrementally read from external APIs. But like I appreciate that is a very customized potential mess. I think with between Kafka, JDBC, and S3 and the various different file types that you have there, obviously like CSV, JSON, Parquet, and Avro, that covers a wider range, covers a very wide range of different sources. But yeah, like our big gap is SFTP and API ingestion. We don't currently have a nice way of ingesting them, in one tool. So what we're currently going for is trying to ingest it in one type of interface and then have multiple tools for the different types of ingestion, ideally as few as possible, but that's kind of where we're going. But yeah, for S3 ingestion, if we wanted to incrementally load S3 data, then there's no reason why we wouldn't use the Hudi streamer for that.
And I think this is one of our last questions that we have. How do you manage all the data sets and data governance in your architecture? I saw some data catalog tools, but can you explain a little bit in short?
So data catalogs and data governance. Okay, so I'll tell you what we have. We have our tooling, our access, everything's done in the Glue data catalog, is in the actual catalog that we're using is just the Glue data catalog. When a repository creates like a pipeline, when the repo is first used to make Kirby pipelines, it gets given a database and it gets given all of the necessary permissions and like a bucket and everything. And then we restrict access to our Glue data catalog with AWS Lake Formation. So we use tag-based access control with AWS Lake Formation to prohibit read access. We have you can define what is PII in the tool, sorry, in the declaration, and then it will then get tagged accordingly in this using the AWS CDK, so in CloudFormation. And that is how we kind of handle human read access control to PII data. In terms of data governance, we kind of have a side, we have our active metadata tool of Data Hub, which we ingest all of our data assets into, and then we provide tooling for these data products creators to either to enrich their assets with metadata to kind of build out their data product. And that's kind of how we're currently doing it. It's definitely an area that we can improve on. But that's roughly what we're doing right now. Does that answer the question?
Yeah, I'll let Ankit respond in the box if that answers his question. Lynn asked, what was the best part of the project?
Who was that, sorry?
Lynn. She asked Lynn asked what was the best part of the project?
The best part of the project was learning together as a team, I'd say, because it is very, very cool to see how it started versus how it is now in terms of, and to see the growth and like the depth and breadth of knowledge increase across the team over that time. So it's kind of like a posthumous, what was the best part of the project? I think a lot of the times during the project, it was just like stressful because it was not working and we didn't know why for a long period of it. But we had flashes of kind of like eureka moments of fixing things that we thought were like hard blockers that weren't hard blockers and that kind of thing, which was good. We faced a lot of issues and we've always been able to get around them eventually, you know, if there is a way to get around them, which has been really, really cool.
Awesome. I think this wraps up our community sync for February. Thanks to everyone who asked questions. Special shout out to Ankit, Lynn, and Sudha. And please join us next month for our March community sync. And we'll be having upcoming events and workshops as well. So stay tuned on the LinkedIn to find out these updates. You can also join our Slack, which is also posted in the comments. And if you haven't already, please start us on GitHub so we can get past the 5K stars. Any last words, Daniel, before we close it in the books for our February community sync?
Keep learning, everyone. That's it. Very, very stoic.
All right, guys. I hope
thank you for having me.
Yeah, I hope everyone has a great rest of their day, and we'll see you soon.
Cheers.
Thanks, everyone.
Thanks.
Bye.
Bye.